Good evening, everybody. Coming to Unit 5, two-port networks and graph theory. Today we discuss two-port networks. What is meant by port? Let us have a network. Let's use the network. Let's have two terminals. Let V1 is the voltage applied to this network. It is having two terminals. This is the current which is entering the network, and same current will be leaving the network. Okay. See, port means it is a pair of terminals. It is having two terminals. It is a pair of terminals at which current may enter. Here current is entering the network. Here current is leaving a network. Here current is entering the network. Here current is leaving the network. Right? Okay. So port means, coming to port means, it is a pair of terminals at which current may enter or leave a network. It is a pair of terminals. Okay. Port means it's a pair of terminals. It's a pair of terminals. Okay. Here we have one pair of terminals, right? Okay. This is one terminal. This is another terminal. Okay. Two terminals means one pair of terminals. Okay. That one pair of terminals is called as a port. So port means it's a pair of terminals at which current may enter or leave the network. Current may enter or leave the network. Okay. It is a pair of terminals at which current may enter or leave a network. Here current is entering. Here current is leaving the network. It's a pair of terminals at which current may enter or leave a network. It's called a port. Okay. A port of a network consists of two terminals. One for the entry of current and other for its exit. Okay. It's a pair of terminals. Port means it's a pair of terminals at which current may enter or leave a network. It's called a port. The currents in the two terminals of a port, okay, this is called a port. See, only one port is having. This network is having only one port. Okay, port means one pair of terminals at which current may enter or leave a network. Okay, the current in the two terminals of a port are equal and opposite. Okay, so here IA is entering, again IA is leaving. These two are equal and opposite. Okay. Port means in French, it means door. This is single port network. Thevenin and Norton equivalent circuits, it is having only one port. It was having one port. This is Thevenin equivalent circuit. This is Norton equivalent circuit. This is Thevenin equivalent circuit. Okay, you can use source transformation to get Norton equivalent circuit from Thevenin equivalent circuit. Vice versa. This is called one port network. One port network. One port network means if the network is having only one port, then the network is called as one port network. Okay, here this is the network which is having only one port. Okay, this is the port. Okay, right? This is network. This network is having only one port. Okay, this is one port, means one pair of terminals. If it is having only one pair of terminals, means this network is called one port network. This network is called one port network. Okay, here Zin means input impedance. Means this is called input port. You are going to find the input impedance between these two terminals. That Zn is equal to Vn by In. V1 is the voltage applied to this port. I1 is the current flowing to this. Then impedance is equal to input impedance is equal to V1 by I1. It is the ratio of V1 to I1. And coming to admittance is the reciprocal of impedance, right? So Yin is equal to I1 by V1. Okay. Input impedance, which is the impedance between these two terminals. Okay, Zn. Okay, Zin is the input impedance between these two terminals. Okay, it is in between these two terminals. Then that will be equal to the ratio of voltage to current V1 by I1. Coming to two-port network. This is called two-port network. Two-port network. Okay, two-port network means the network is having two ports. Okay, this is port 1, this is port 2. Okay, this is port 1, port 1. This is port 2. If the network is having two ports, then the network is called as two-port network. Called as a two-port network. Okay. Otherwise, if the network is having two pairs of terminals, okay, this is one pair of terminals. Okay, this is another pair of terminals. Okay, one pair of terminals is nothing but one port. So it is having four terminals, means two pairs of terminals. The network is having two pairs of terminals, then the network is called as a two-port network. This is called input port. This is port 1. Port 1 is called input port. Input port. Port 1 is called input port. Whereas port 2 is called output port. Output port is called output port. V1 is the voltage which is applied at port 1, means which is applied at input port. V2 is the voltage which is applied at port 2, means output port. This is the voltage which is applied at port 2 or output port. Coming to Y parameters, here we are going to have Z parameters, Y parameters, H parameters, transmission parameters. These are all two-port networks. First, let us discuss Y parameters. V is equal to Iz. You know V is equal to Iz, right? V is equal to I into 1 by Y, because admittance is the reciprocal of impedance. Okay, from this I is equal to Vy, or I is equal to YV. I is equal to YV. We know V is equal to Iz. V is equal to I into 1 by Y, because Y is what? Y is admittance. Y is admittance. Y is equal to 1 by Z. It is the reciprocal of impedance. It is the reciprocal of impedance. Admittance is the reciprocal of impedance, right? Okay, so here this can be written as I is equal to Vy, I is equal to Yy, I is equal to Yv. Okay, from this equation can be written in matrix form like this. I can be written in matrix form like this: I1, I2, 2 by 1 matrix, which is equal to anyhow we have two currents and two voltages, right? So this will be V1, V2, and this will be I1, I2. Okay, then we are going to have four parameters: Y11, Y12, Y21, Y22. Okay, This is in matrix form. 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 Right? Okay. So from this, what is I1? I1 is equal to this row into this column. Okay. Then I1 is equal to Y11 V1 plus Y12 V2. Product of this row and this column. Okay, then I1 is equal to Y11 V1 plus Y12 V2. Coming to I2, I2 is equal to product of this row and this column, right? Then Y21 V1 plus Y22 V2. Y21 V1 plus Y22 V2. So we have what is I1? Y11 V1 plus Y12 V2. What is I2? I2 is equal to Y21 V1 plus Y22 V2. Y22 V2. So here we are going to find Y11, Y12, Y21 and Y22. All are Y terms. Y terms. Y terms. Y terms are called admittance parameters. These Y terms are called as admittance parameters. Y parameters or admittance parameters. Admittance parameters or Y parameters or Y parameters. Y parameters. Right. How can I find Y parameters? See, if I make V2 0, if I make this V2 0, so if I make V2 0, then I can find Y11. Y11 will be equal to I1 by V1, and when you make V2 0, then what will be Y21? Y21 is equal to I2 by V1. I2 by V1. When V2 is 0. When V2 is 0. We don't have network like this. This is network. It's port 1. This port 2. V1, V2, I1, I2, right? Making V2 0 means what? Making V2 is 0 means, short circuiting port 2. Short circuiting port 2. If you short circuit port 2, then only you can make V2 0. So making V2 0 means short circuit this port 2. If a short circuit port 2, then output port, then V2 becomes 0. V2 becomes 0. Anyhow, I2 will be flowing. I2 will be flowing, right? Then here, this will be V1, this will be I1. If you have network like this, then you can find Y11 is equal to I1 by V1 when V2 is equal to 0. When V2 is equal to 0. We can find Y21 is equal to I2 by V1, I2 by V1 when V2 is equal to 0. Similarly, we can find other two parameters. What are they? Y12 and Y22. Okay, here Y12 and Y22. How can you find Y12 and Y22? By making V1 as 0. If you make V1 0, if you make this V1 0, then you can find Y12. If you make this V1 0, then you can find Y22. Okay, by making V2 0 means, sorry, by making V1 0 means short circuiting port 1. Short circuiting port 1. Okay, short circuiting port 1, then V1 becomes 0. Anyhow, I1 will be flowing. I1 will be flowing. Is what V2 is I2. Right? Then you can find Y12, which is equal to Y12 is equal to I1 by V2. I1 by V2 when you make V1 0. When V1 is equal to 0. What is Y21? Y21 is equal to I2 by V1 when V1 is equal to 0. When V1 is equal to 0. Y11. Y11 is called short circuit input admittance because you are going to find Y11 at input port. Okay. Y11 is equal to I1 by V1. You are going to find admittance at input port. That's why anyhow by short circuiting port 2 you are getting Y11, right? That's why Y11 is called short circuit short circuit short circuit short circuit input admittance. Short circuit input 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 admittance. Input admittance. Short circuit input admittance. Here again it is short circuit short circuit short circuit transfer admittance. Transfer 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 admittance. Transfer admittance because it is the ratio of I2 to V1. I2 to V1. Okay. Current at port 2, voltage at port 1. Okay, that's why it is called short circuit. Anyhow, by short circuiting port 2, you are getting this term, right? That's why it is called short circuit transfer admittance. This is called short circuit input impedance because you are going to find admittance at input port. That's why it is called short circuit input admittance. Coming to this is called Y12. Y12 is called short circuit transfer admittance. Is called short circuit transfer admittance. Coming to Y21. Sorry, this is what sorry, this is y22. Y22 is equal to I2 by V2. I2 by V2. Y22 is equal to Y22 is equal to I2 by V2. Okay, then this is called short circuit, short circuit, short circuit output admittance, output admittance. Y2 is called short circuit output admittance because you are going to find admittance at output port. You are going to find output admittance at output port. That's why it is called short circuit output admittance. Short circuit output admittance. Okay. So here Y11 comma Y21 can be obtained by short circuiting port 2. By short circuiting port 2, right? Okay. Y11 comma Y21 can be obtained by short circuiting port 2. Y12 comma Y22 can be obtained by short circuiting port 1. Means all parameters, all Y parameters can be obtained by short circuiting either port 1 or port 2. All parameters can be obtained by short circuiting either port 1 or port 2. Then these parameters are called as short circuit parameters. That's why you're going to get all Y parameters by short circuiting either port 1 or port 2. That's why these parameters are called short circuit parameters. These parameters are called short circuit parameters. This Y1 is also called as driving admittance. This Y11 is also called as driving admittance. This Y22 is also called as driving admittance. Y12 and Y21 are called transfer admittances. Okay. Y11 comma Y22 are called driving admittances, whereas Y12 and Y21 are called transfer admittances. Here, when you make when you short circuit port 2, okay, you're going to get Y11. When port 2 is short circuited, then you're going to get Y21. Okay, so these two parameters can be obtained by short circuiting port 2. These two parameters can be obtained by short circuiting port 1. Okay, here the Y12 is called transfer admittance. Y21 is also called as transfer admittance. Y11 is called input admittance. Y22 is called output. Y22 is called output admittance because this is the admittance seen looking into the port 2 when port 1 is short circuited. You're going to find admittance at port 2 by short circuiting port 1. That's why it is called output admittance. Now coming to condition for reciprocity. So here we have to apply reciprocity theorem. If the network obeys reciprocity theorem, then it is called as, then the network is said to be reciprocal. Okay. If the network obeys reciprocity theorem, then the network is said to be reciprocal. Then the network is said to be reciprocal. Okay. The network is said to be reciprocal if the network obeys reciprocity theorem. Okay, you know reciprocity theorem, right? The ratio of response to excitation is constant even though the input and output terminals are interchanged. Okay, so you interchange the input and output terminals, then the ratio of response to excitation will be constant. Okay, so here in this network, what is the ratio of response to excitation? The ratio of response to excitation is I2 by B1. Coming to this network, what is the ratio of response to excitation? I1 by V2. Okay, if these two are equal, then the network is said to be reciprocal. Then the network is said to be reciprocal. It means this network obeys reciprocity theorem. Okay. So this is nothing but what? This is nothing but y21. This is nothing but what? y12. Okay. That's why the network is said to be reciprocal when y12 is equal to y21. When y12 is equal to y21, then the network is said to be reciprocal. Condition for symmetry. Here. Let us take one network. This is 4 ohms, 1 ohm. This is 1 ohm. This is 4 ohm, right? This network is said to be this network is said to be symmetrical. Okay, this network is reciprocal as well as symmetrical. Okay, you find y21 and y12 both will be equal in this case. Okay, for this network, both are equal. Means this network is reciprocal. Okay, coming to symmetry, condition for symmetry is a two-port network is said to be symmetrical if its ports can be interchanged without changing the port voltage and currents. Okay. So even though you change input port and output port, even though you interchange input and output ports, network doesn't change. Network doesn't change. Okay. Otherwise, a symmetrical network is a network which is divided into two equal halves, with each half as a mirror image of the other. In other words, if the network looks same from both the ports, then it is called symmetrical network. Then it is said to be symmetrical network. To divide this network into two halves, two equal halves, okay, then this is mirror image of this, right? So this network is said to be symmetrical. This network is said to be symmetrical. Otherwise, even though if you interchange two ports, this network doesn't change. Okay, so for symmetric network, I1 by V1 is equal to, I1 by V1 is equal to I2 by V2. I1 by V1 when V2 is equal to 0, I2 by V2 when V1 is equal to 0. Okay, then Y11 is equal to Y22. So the network is said to be symmetrical when Y11 is equal to Y22. Here, input impedance is equal to output admittance. Sorry. Input admittance is equal to output admittance. Okay, then the network is said to be reciprocal. Then Y11 is equal to Y22. Let us find Y parameters for this network. Find the Y parameters of the circuit shown below. Is the network reciprocal or symmetrical? Here, how can you find Y parameters? You know, right? Here, the first you write like this: I is equal to YB. Then in matrix form, I1, I2 is equal to Y parameters V1, V2, V1, V2, Y11, Y12, Y21, Y21, Y22, Y22. Okay, then you know, right? Y11 is equal to what? Y11 is equal to I1 by V1. I1 by V1 when V2 is equal to 0. Similarly, y21 is equal to I2 by V1 when V2 is equal to 0. You remember like this. You know, right? Admittance. What is admittance? Admittance is the ratio of current to voltage. It is the ratio of current to voltage because it is the reciprocal of impedance. It is the reciprocal of impedance, right? So admittance is the reciprocal of impedance, and it is equal to the ratio of current to voltage. So y11 y is equal to, it is the ratio of current to voltage. So current to voltage. It is the ratio of current to voltage. Again, here also ratio of current to voltage. Even if you take y12 is equal to, you are going to get I1 by V2 when V1 is equal to 0. Similarly, y22 is equal to I2 by V2 when V1 is equal to 0. Okay, you remember like this. Anyhow, all y parameters are equal to the ratio of current to voltage. Here is the current to voltage. Ratio of current to voltage. Again, here also current to voltage. Ratio of current to voltage, right? Okay, here see y11 means this is first subscript. This is second subscript. Okay, so here you will be having, in numerator you will be having first subscript. In denominator you will be having second subscript. Similarly here y2 is first subscript, whereas second subscript is 1, right? So in numerator you write first subscript, that is 2. In denominator you write second subscript, means 1. Okay, then I2 by V1. Y12 first subscript is 1, then I1 second subscript is 2, then you write V2. Okay, first subscript and second subscript both are 2, right? Then you write I2 by V2. Okay. Then first, what is y11? Y11 is equal to, it is the ratio of I1 to V1 when V2 is equal to 0. So we short circuit port 2. Okay, this is port 2. Okay, you short circuit this port. Okay, short circuiting the port. Actually, you are having one resistance, 15 ohms resistance. Okay, you are short circuiting port 2. Okay, this is short circuited. When this is short circuited means no current will be flowing. No current will be flowing through this resistance. Right? Okay. Then here V2 is short circuited. Okay. Then what will be the ratio of I1 to V1? Okay, nothing but you are going to find the input impedance between these two terminals. Input admittance between these two terminals. Okay. So here V1 is equal to 20 into IA. If IA is the current flowing through this, okay, IA is equal to 5 by 25 into I1. Okay, you can use current division rule. Okay, I1 is total current. Okay, IA is the current flowing through this. So current flowing to 20 ohm resistor is equal to total current into opposite resistance is 5 ohm. Opposite resistance by total resistance means 20 plus 5. Okay, then you are going to get IA. Okay, put this IA in this, then you are going to get the ratio of I1 to V1, that is equal to 1 by 4 Siemens or mho. Unit of admittance is mho or Siemens. Okay. Similarly, what is V1? V1 is, you have to get V1 in terms of I2. In order to find Y21 is equal to I2 by V1 when V2 is equal to 0. Okay, you take the same circuit and find the ratio of I2 to V1. Okay, so here What is this? What is the voltage across 5 ohm resistor? Okay, you have network like this. The voltage between these two is what? V1. The current flowing through this is I2. Resistance of this is 5 ohms. Then V1 is equal to minus 5 I2. Minus 5 I2. Then the ratio of I2 to V1 will be minus 1 by 5 mole or Siemens. Here, voltage at this point with respect to this point is equal to minus 5 I2, because I2 is flowing in this direction. Then the current which is flowing in this direction would be minus I2. Then V1 is equal to minus I2 into 5. Then you can get the ratio of I2 to V1 is equal to minus 1 by 5 Siemens or moles. Now you short circuit port 1, V1 is equal to 0. Okay, if you have to short circuit this port 1. Now you short circuit this port 1. If you short circuit this port 1, then no current will be flowing to this. Okay, then you are going to have circuit like this. Then you are going to have circuit like this. Okay, V1 is 0, right? Here, let Ix is the current flowing to this. Otherwise, you can also use KCL. You can apply node analysis. You apply KCL at this node. Okay, then also you will get the ratio of I2 to V2. Okay, simply the ratio of I2 to V2 means you are going to find output admittance between these two terminals. Okay, after finding impedance, if it is, after finding impedance also you can find admittance. Okay, so simply here V2 is equal to 15 Ix, Ix is equal to total current is I2. Okay, the current which is flowing through this is equal to total current I2 into opposite resistance by total resistance. Okay, 5 by 25. Okay, substitute this in this equation, then you are going to get the ratio of I2 to V2 which is equal to Y2 which is equal to 4 by 15 Siemens. Now coming to Y12. Y12 is the ratio of I1 to V2. I1 to V2. Okay, so here I1 to V2, right? So what will be V2? What will be V2? V2 is the voltage between these two terminals, or voltage between these two terminals, because these two are in parallel. Okay, what will be voltage at this point with respect to this point is V2, which is equal to minus 5 I2. Sorry, minus 5 I1. Okay, then you can get the ratio of I1 to V2, which is equal to minus 1 by 5 Siemens. Okay, then here see this is Y11, Y12. Okay, you can have like this Y11, Y12, Y21, Y22. Okay, here see Y1, this is what? This is Y12. Y12 is equal to Y21. Y12 is equal to Y12 is equal to Y21. Okay, if Y12 is equal to Y21 means the network is said to be reciprocal. The network is said to be reciprocal. Okay, coming to symmetry, Y11 is not equal to Y22 here. Here Y11 is not equal to Y22 means it is not symmetrical. This network is not symmetrical. This is only reciprocal because Y12 is equal to Y21. Okay, finding Y parameters for this circuit. Is the network reciprocal or symmetrical? Here, finding Y11 is equal to what? Y11 is equal to what? I1 by V1. I1 by V1. When V2 is equal to 0. When V2 is equal to 0. Now you short circuit this port. Then V2 becomes 0. Okay, V2 becomes 0. Then no current flows through this capacitor. If it gets short circuited, no current flows through this capacitor. Okay, then you're going to have the circuit like this. You're going to have the circuit like this. When you make V2 is equal to 0. Here, when V2 is equal to 0. When V2 is equal to 0. When V2 is equal to 0, we're going to find Y11 and Y21 by making V2 0. Then here see, voltage at this point with respect to this point is what? 10 I2. 10 I2. Voltage at this point with respect to this point is what? Is what? It is minus 10 I2. Minus 10 I2. Okay. Here then I2 here see the voltage between these 2 points is 10 I2. The voltage at this point with respect to this point is minus 10 I2. Minus 10 I2. Okay. Then I2 becomes 0. Then I2 becomes 0. Okay. If I2 is 0 means, if I2 is 0 means no current is flowing to this. If I2 is 0 means this is dependent voltage source. This is dependent voltage source. Okay. If I2 is 0 means this becomes 0. This becomes 0. Then you are going to have network like this. Short circuit. This is voltage source, dependent voltage source. To make I2 0 means this will become 0. Means voltage source is 0 means replaced by short circuit. Then you are going to have circuit like this. Okay. Then the current which is flowing to this is I2. Anyhow, this will be 0. Anyhow, this will be 0. Okay, it is short circuited. Then the voltage between these two is V1. Here it is I1. Then V1 is equal to simply 2 plus J4 into I1. Then we can get the ratio of I1 to V1 is equal to 1 by 2 plus J4. 1 by 2 plus J4. Okay, similarly Y21. Y21 is equal to, it is the ratio of I2 to V1. Okay, anyhow I2 is 0. 0 by V1 is equal to 0. 0 Siemens. Okay, similarly, short circuit this port. Short circuit this port now. Port 1. To short circuit port 1, then V1 becomes 0. V1 becomes 0. Then you are going to have the circuit like this. Okay. First you find I1. Okay. Here see, this is total current is I2. Okay. I1 is the current flowing to this. Okay. So here, what is I1? I1 is equal to minus 10 I2 by 2 plus J4. 2 plus J4 means voltage between these 2 points is 10 I2. Then voltage across this impedance is also 10 I2. Okay, so voltage at this point with respect to this point is 10 I2. So 10 I2 is equal to minus I1 into 2 plus J4. 2 plus J4. Okay. From this you are going to have the equation like this. Okay. I1 into 2 plus J4 is equal to minus 10 I2. Okay, because voltage between these 2 points is equal to voltage across this impedance. Voltage across this impedance. Okay, that's why voltage at this point with respect to this point is minus I1 into 2 plus J4. Voltage at this point with respect to this point is 10 I2. That's why you make both equal, then you are going to get this equation. coming to here, see, we are applying KCL at this node. KCL at this node. If I apply KCL at this node, V2 by I2 is equal to, I2 is incoming current. These two are outgoing currents. Okay. So I2 is equal to V2 by minus J20 plus V2 minus, okay, voltage at this point. This node voltage is 10I2. 10I2 is this node voltage. Okay, then the current which is going to this is V2 minus 10I2 by 10. Okay, then we are going to get this equation. Okay, after solving these two equations, we are going to get Y22 and Y12. Okay, in matrix form, you can have admittance like this. This is not reciprocal. This is neither reciprocal nor symmetrical, because Y11 is not equal to Y22, Y12 is not equal to Y22. Z parameters. The network is having two ports. This is called input port. This is called output port. Okay. V1 is the voltage applied at input port. V2 is the voltage applied at output port. Okay. Here you can write like this, right? P is equal to IZ. Okay. P is equal to Z into I. Z into I. Okay. In matrix form, this can be written like this: V1, V2 in matrix form. In matrix form, which is equal to Z11, Z12, Z21, Z22 into I1, I2. Okay, then V1 is equal to Z11 I1. Okay, this V1 is equal to this into this, multiplication of this row into this column, plus Z12 into I2. Similarly, V2 is equal to Z21 I1 plus Z22 I2. Okay. How can we get these parameters? Here Z terms, Z11, Z12, Z21, Z22, all are Z terms. These Z terms are called as impedance parameters. Okay, Z11, Z12, Z21, Z22, all are impedance parameters. Okay, these terms are called Z terms are called impedance parameters. Okay, now how can I find these Z parameters? Okay, let me make this current 0. Okay, if I make this current 0, I2 0, okay, this is the actual network. Okay, network. So this is port 1 and this is port 2. V1, so this is V2, this is V1. I1, I2. Okay, so making I2 0 means what? Making I2 0 means open circuiting port 2. Okay, if it is open circuited, then I2 becomes 0. Okay, the current which is flowing through this is I2. I2 becomes 0. Okay, the voltage between these two points. The voltage between these two points is V2. V2. Okay. Input voltage I1 is the current voltage. If you make I2 0, making I2 0 means open circuiting port 2. Open circuiting port 2. If you open circuit port 2, then you're going to get Z11. Z11 is equal to V1 by I1. V1 by I1 when I2 is equal to 0. When I2 is equal to 0. Okay. Then Z21. Z21 is equal to V2 by I1. V2 by I1 when I2 is equal to 0. Then I2 is equal to 0. Okay. Now let us find Z12 and Z22. If I make this 0, if I make I1 0, okay, then you can find Z12 and Z22. Okay, then what will be the network? Okay, you're going to find Z12 and Z22 by open circuiting port 1. Okay, then here I1 is equal to 0. Okay, anyhow you can get voltage across this V1. Okay, just you are making I1 0. Okay, V2 and what here the voltage is applied. Here voltage applied to this. This is V1. Okay, then Z12 is equal to V1 by I2. V1 by I2 when I1 is equal to 0. When I1 is equal to 0. Z22 is equal to V2 by I2. V2 by I2 when I1 is equal to 0. When I1 is equal to 0. So here see Z11 comma Z21 can be obtained by open circuiting port 2. By open circuiting port 2. That's why these these parameters are called open circuit parameters. Again, Z12 and Z22 can be obtained by open circuiting port 1. By open circuiting port 1. Z11 and Z21 can be obtained by open circuiting port 2. Port 2. Okay, then Z11, Z21, Z12, Z22 can be obtained by open circuiting either port 1 or port 2. That's why these parameters are called open circuit parameters. Open circuit parameters. Open circuit parameters. Open circuit parameters. These parameters are called open circuit parameters. Open circuit parameters. Because these parameters can be obtained by open circuiting either port 1 or port 2. That's why these parameters are called open circuit parameters. Where Z11, okay, Z11 and Z22 are called driving impedances. Z11, Z22 are called driving impedances. Z12, Z21 are called transfer impedances. Here Z11 is called input impedance. Z22 is called output impedance. Here Z11 is called open circuit input impedance. Z22 is called, it is somewhat difficult to write. That's why I'm telling. Z11 is called open circuit input impedance, because you're by open circuiting port 2 you're getting Z11. That's why it is called open circuit input impedance. Okay, Z22 is called open circuit output impedance, because you are finding impedance at port 2. Impedance at port 2. You're going to find the impedance at port 2. Okay, that's why it is called output. That's why Z22 is called output impedance, open circuit output impedance. Z11 is called open circuit input impedance. Okay, Z22 is called open circuit output impedance. Z21 is called open circuit transfer impedance. Z12 is also called as open circuit transfer impedance. The network is said to be reciprocal when Z12 is equal to Z21. When the network is said to be symmetrical when Z11 is equal to Z22. This is the given circuit. We are asked to determine the Z parameters. We can find Z parameters by open circuiting either port 1 or port 2. Okay. Now let us find Z11. Z11 means, what is Z11? Z11 is equal to V1 by I1. V1 by I1. See here. See. Z means impedance. Impedance means it is the ratio of voltage to current. Okay. So in all Z parameters are equal to the ratio of voltage to current. Ratio of voltage to current. Okay. This is first subscript. This is second subscript. Okay. So V1 by I1. This is first subscript. So in numerator you take first subscript, in denominator you take second subscript. Then V1 by I2. Z21 is the ratio of V2 by I1. You take first subscript in numerator, second subscript in denominator. Okay, so you remember like this. Okay, then Z11 can be written as, anyhow Z is the ratio of voltage to current, so voltage to current, and first subscript is 1 and second subscript is 1. So that's why it is the ratio of V1 to I1. V1 to I1 when I2 is equal to 0, because all Z parameters are open circuit parameters. Either you make port 1 open circuit or port 2 open circuit. Okay, so I1 is present means I2 will be 0. Okay, so you open circuit this port 2. Okay, you open circuit this port 2. Okay, then I2 becomes 0. Okay, so here I2 is 0. Here open circuiting is port 2. Your open circuiting is port 2. Is kept open circuited. Okay, you can find V2. You can get V2. Okay, so here restore in series. If it is open means restore in series. This series combination is in parallel with this. Okay, this total resistance, this resistance is in series with 8 ohms. Then 8 plus 20 in parallel with 10 plus 20. Okay, then you are going to get Z11. Similarly, Z22. Z22 is equal to V2 by I2. V2 by I2 when I1 is equal to 0. When I1 is equal to 0. Okay, so you open this port. If you open this port, I1 becomes 0. Then you can find Z22 and Z12. Okay, Z22 is what? V2 by I1. Sorry, V2 by I2. Okay, when I1 is 0. What is Z12? Z12 is V1 by I2 when I1 is 0. Okay, so from this circuit you can find Z22 and Z12. Okay, Z22 is equal to Z22 is equal to, anyhow it is open, right? Z22 is the ratio of V2 to I2. Okay, then you can find the equivalent impedance. If it is open means no current will be flowing to this. Then these two are in series, 10 plus 20. 10 plus 20, this resistance in parallel with 20. Then 20 in parallel with 30. Then you are going to get 12. Then you get Z22. Okay, Z12. When you make I1 0. Okay, so V1 is equal to here V1 is equal to voltage across 20 ohm resistor. Voltage across 20 ohm resistor. Okay, then here you can write like this. Okay, here V1 is equal to current to this multiplied by resistance. Okay, it is given, right? Okay, current to this multiplied by 20. You're going to find the current flowing to this. Okay, when you open this port. Okay, then what will be the current flowing to this? Okay, what is the current flowing to this? This current is equal to, that current is equal to, total current is I2 into opposite resistance is 20 by total resistance is 20 plus 10. Okay, this is opposite resistance. Okay, total resistance will be 20 plus 10 plus 20. Okay, 20 plus 30. Okay, both are same. Okay, this is the current flowing through 20 ohm resistance. Okay, so current multiplied by resistance gives 8I2. Then the ratio of V1 to I2 is equal to 8. You're going to get Z12 is equal to 8. Okay, you can find other parameters. Okay, all are complete, right? So we can have Z parameters in matrix form. Okay, you can write like this: V1 V2 is equal to 28 8 12 I1 I2. Here this is Z11. Z11 is equal to 20. Z12 is 8. Z21 is 8. Z22 is 12. Here Z12 is equal to Z21. Okay. Then the network is said to be reciprocal. The network is said to be reciprocal. Let us solve this problem. We have to find Z parameters. So now Z11 means I2 will be 0. So this is open circuited. Right? I2 will be 0. When I2 is 0 means here see, if you apply KCL at this node, then I1 is equal to V1 by Vx by 1 plus Vx plus, anyhow will not touch this branch, anyhow no current is going to this. Then you take this as single branch, then Vx plus 2Vx you apply KCL at this node, right? Okay, then Vx by 1 Vx plus 2Vx by 6. Okay, then you are going to get the like this. Okay, then I1 is equal to 3Vx by 2. Okay, here Vx is equal to, here see, you apply KVL around this loop, then you are going to get this. Vx is equal to V1 minus I1. Okay, substituting gives I1 is equal to 3 into V1 minus I1 by 2. Then you are going to get V1 by I1 is equal to 5 by 3. Okay. Similarly, you can find all values. Okay, I'll do one thing. Let us find one value Z12. Okay, let us find Z12. That is Z21. Let us find Z21. 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 Z21 is equal to V2 by I1. V2 by I1. When I2 is equal to 0. When I2 is equal to 0. This will be 0. This will be 0. Okay. So this voltage is Vx. Okay. This is same as this circuit, right? Okay. Then we are going to get. Then we have to get the ratio of V2 to I1. V2 to I1. Okay. You know, V1 by I1 is equal to V1 by I1 is equal to 5 by 3. 5 by 3. Okay, you got this, right? Okay. So let us find V2. V2. You apply KCL at this node, then you are going to get Vx by 1 plus Vx plus 2Vx by 6 plus is equal to I1. Is equal to I1. Let's here. You apply KVL around this loop. Here you know, let I dash is current going this. Then V2 is equal to I dash into 6 plus 6 minus 2Vx. 6 minus 2Vx. Okay, this is what. V2 is the current flowing to this into 2 plus this voltage, right? Sorry. V2 is equal to 2 I dash. 2 I dash minus 2 Vx. Minus 2 Vx. Let us find I dash. What will be I dash? I dash is equal to Vx plus 2Vx by 6. Okay, because I dash is the current flowing to this. Okay, then you can find I dash. I dash is equal to Vx plus 2Vx. Okay, because Vx is the node voltage here. Okay, then we'll get this, which is equal to 3Vx by 6. 3Vx by 6. Okay. Then if you substitute this in this equation, then you're going to get V2 is equal to, this is what, 1 by 2. Okay, then Vx minus 2Vx, which is equal to minus Vx. So V2 is equal to minus Vx. V2 is equal to minus Vx. Okay. So here V2 is equal to minus Vx. Okay, you know, right? 3Vx by 2. Here already you know I1 is equal to 3Vx by 2. Okay, we got V2 is equal to minus Vx. Then I1 is equal to minus 3 V2 by 2. 3 V2 by 2. Okay, then from this, what will be the ratio of V2 to I1? V2 to I1 will be equal to minus 2 by 3. Okay, Z21 is equal to minus 2 by 3. Okay. Z21 is equal to minus 2 by 3. Okay. Similarly, you can solve other two parameters. Here, see, from y parameters to z parameters. Okay, you know, I is equal to yb, b is equal to zi. Okay, b is equal to zi. In place of z, you write y inverse. Okay, here see, I is equal to vy. Means what will be v? V is equal to y inverse I. Okay, here v, here also v. So you make these two equal. You make these two equal, then y inverse I is equal to z into I. Means z is equal to y inverse. So z is equal to y inverse. Okay. So here you know z is equal to mean z11, z12, z21, z22 is equal to y inverse. Okay. You know y parameters, right? What are y parameters? y11, y12, y21, sorry, y21, y22. Okay, getting inverse of this, then you are going to get like this. Okay, then it is equal to z parameters. So we have to unsolved problems. We can solve all these problems. Now let us discuss h parameters. H parameters are also called as hybrid parameters. H parameters are also called as hybrid parameters. Okay. So here we're going to find H parameters, right? Okay. You do one thing, you write like this: V1, V2, I1, I2. Okay. You put an arrow like this, put one more arrow like this. Okay, then you take V1, V1, I2, V1, I2. This is equal to H into I1, V2, I1, V2. Okay. So you remember like this. First you write V1, V2, I1, I2. You put two arrows. Then follow the directions of those arrows. V1, I2 and I1, V2. Okay. V1, I2, H is equal to H into I1, V2. Okay. V1, I2 is equal to H into I1, V2. H means H11, H12, H21, H2. This is V1. In matrix form, it can be written as V1, I2 is equal to H11, H12, H21, H22 into into I1, V2, I1, V2. Okay. So in scalar form, see this is equal to V1 is equal to this into this. So V1 is equal to H11 I1 plus H12 V2. I2 is equal to this. I2 is equal to this into this. So H21 I1 plus H22 V2. The following is popular model used to represent a particular variety of transistors. Okay. The network is said to be reciprocal if H12 is equal to minus H21. If H12 is equal to minus H21, the network is said to be reciprocal. The network is said to be symmetrical if H11, H22 minus H12, H21. is equal to 1, then the network is said to be reciprocal. Then the network is said to be symmetrical. Okay. Take this slide to get h parameters. Okay. If I write equations, y1 is equal to y1, this is I2. Okay. Sorry, v1 is equal to h11 I1 plus h12 v2, h12 v2. I2 is equal to h21 I1 plus h22 v2. Okay. Make v2 is 0. Make v2 0 in order to find h11. Okay. So short circuit port 2. Then v2 will be 0. v2 becomes 0. Okay. Short circuit port 2. Okay. Then you can apply v1 here. This will be I1. Okay. The current which is going to this is I2. Okay. This is network. Then h11 is equal to what? h11 is equal to v1 by I1. v1 by I1 when v2 is equal to 0. h21 is equal to I2 by I1 when v2 is equal to 0. Okay. Means by short circuiting port 2 you can get h11 and h21. Okay. Coming to h12 and h22, if I make I1 0 in this equation, then you are going to get v1 is equal to h12 v2. Then if I make I1 0 in this equation, then I2 is equal to h22 v2. Okay. So making I1 0 means open circuit port 1. Then we can make I1 0. I1 is equal to 0. Okay. This is v2. The current which is going to this is I2. So then you can find h12 is equal to v1 by v2. Okay. h22 is equal to h22 is equal to I2 by v2. When I1 is equal to 0. When I1 is equal to 0. Okay. So by open circuiting port 1, you are going to get h12 and h22. By short circuiting port 2, you are going to get h11 and h21. That's why these parameters are called short circuit parameters. These parameters are called open circuit parameters. Okay. Here h11, where is h11? Here, right? h11 is called by short circuiting port 2. You are going to get h11, right? So h11 is called short circuit. What is the ratio? It is the ratio of voltage to current, right? Short circuit input impedance. Impedance is measured in ohms. Admittance is measured in Siemens or Mohs. Okay, short circuit input impedance. Okay, ratio of voltage to current means impedance. Okay, which is finding at input port, means this will be input impedance as it is, as the port 2 is short circuited. When the port is short circuited, when the port 2 is short circuited, then this H11 is called short circuit input impedance. Now coming to H22. Okay, H22 is called short circuit. Anyhow, by short circuit in port 2 you are going to get H21. That's why it is called short circuit, short circuit, short circuit forward, forward, forward current gain, 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 short circuit forward current gain, because it is a ratio of I2 to I1. Okay, I2 to output current, input current, ratio of output current to input current means gain. Okay, forward gain, forward current gain, short circuit forward current gain. Okay, coming to this. Okay, H12, H12 is the ratio of V1 to V2, V1 to V2. Okay, anyhow by open circuiting port 1 you are going to get H12, right? So this is called open circuit, open circuit reverse voltage gain, reverse voltage gain, because it is not the ratio of V2 to V1, it is the ratio of V1 to V2. That's why it is reverse voltage gain. Okay, coming to this, again you are going to get this H22 by open circuiting port 1. That's why it is open circuit, open circuit, open circuit. It is the ratio of current to voltage, current to voltage, ratio of current to voltage means admittance. Open circuit output admittance, you're going to find admittance at output port. So that's what it's called, open circuit output admittance. Let's find hybrid parameters for this circuit. So here, so this H11, H11 is equal to V1 by I1 when V2 is equal to 0. Okay, next, what will be, what is H21? H21 is equal to V, sorry, H21 is equal to I2 by I1 when V2 is equal to 0. Okay, so short circuit is 4, then V2 will be 0. Then the current which is going to this is I2. Okay, the current going to this is I1 plus minus V1, voltage operated port 1. Okay, then what is the ratio of V1 to I1? Ratio of V1 to I1 means impedance. Okay, you find total impedance. Okay, 3 ohms, 6 ohms, these two are in parallel. Okay, which is equal to 2 plus 6 in parallel with 3 ohms. Then you are going to get the ratio of V1 to I1. Nothing but input impedance. Okay, simply V1 into V1 is equal to I1 into total impedance. Nothing but the ratio of V1 to I1. Okay, coming to this H21. H21 means it is the ratio of I2 to I1. Okay, so do one thing, you find I2 in terms of I1 or I1 in terms of I2. So here what is I2? You take current in this direction, then minus I2. Minus I2 is equal to, minus I2 is equal to total current I1 into, okay, opposite resistance 6 by total resistance 6 plus 9. Then we can get H, sorry, H, you can get H21, which is equal to, what is the ratio of I2 to I1? I2 to I1 is equal to minus 6 by 15. Okay. Similarly, let us find, I'll take 10 more minutes. Let us find H12. H12. Okay. H12 is equal to V1 by V2. V1 by V2 when I1 is equal to 0. What will be the circuit? The circuit will be like this. It is open. It is open means the current which is going through this is 0. Port 1 is open circuited. This is 6 ohms. Okay. This is 3 ohms. Okay. Voltage between these two is V2. Okay. Current going this is I2. Okay. So here voltage between these two is V1. It is open circuited only. If it is open circuited, voltage between these 2 points is nothing but voltage between these 2 points. Anyhow, these two are open. These two terminals are open. Means voltage between these 2 points is V1. You are calculating voltage. You are not applying any voltage here. Okay, voltage between these 2 points. Anyhow, no current flows resistant. Then voltage between these 2 points. Okay, means V1 is voltage across 6 ohm resistor. Then V1 is equal to, you use voltage division rule, total voltage V2 into opposite resistance, that particular resistance is 6 by 6 plus 3. Then what is the ratio of V1 to V1? V1 to V2? It is H12 is equal to 6 by 9. Similarly, you can find H22. What is H22? Okay. H22 is equal to I2 by V2. I2 by V2. Okay, which is equal to I2 by V2. Okay, simply 3 plus, sorry, what is the ratio of I2 by V2, right? So it is equal to I2 by, what is V2? V2 is equal to 3 plus 6 into I2. 3 plus 6 into I2. Then you are going to get H22 is equal to 1 by 9. You can check whether it is reciprocal or not, symmetrical or not. Let us go for this problem. Here see H11 and H21. Okay, by short circuiting port 2. By short circuiting port 2. Okay, V2 is equal to 0. Okay, you apply KCL at node 1, this node. Okay, then I1 is the current going to this. I1 is equal to V3 by 2 plus V3 minus V4 by 2. Okay, from this you will get my equation. You apply KCL at node 2, this node. Then plus 4I1 plus V3 minus, see, this is incoming current, this is also incoming current. Okay, so you want to apply KCL at this node, then V3 minus V4 by 2 plus 4I1, then this is outgoing current. Okay, which is equal to V4 by 1. Then you are going to get this equation. Okay, then by solving those two equations, okay, again we have, right, you can get this. Okay, again you have V3 is equal to 3V4 minus 8I1. Okay, from this you can find this. Okay, V1 is equal to V3 plus I1 by solving these two equations. Okay, by solving these two equations, you are going to get the ratio of V1 to I1. You are going to get the ratio of V1 to I1. Okay, which is equal to 3.8 ohms. 0.8 ohms. Next, I2 is equal to minus V4 by 1. Okay, this I2 is equal to the current which is flowing through this is anyhow node voltage V2, V4. V4 is the node voltage, right? Okay, voltage across this is V4 only. So V4 is equal to minus 1 into I2, minus 1 into I2. Okay, then you can get I2 is equal minus V4 by 1, which is equal to minus 3.6 into I1. Okay, use this equation. So then we will get H21. H21 is equal to I2 by I1, which is equal to minus 2. Okay, similarly by open circuiting port 1, we can get H22 and H12. Okay, and now you apply KCL at this node. You apply KCL at this node. Okay, by using node analysis or by using any other methods also, you will get the ratio V1 to V2. Okay, here see, here let us use voltage Gibson rule. Okay, here see V1 is equal to this V1 is equal to voltage across this. Okay, okay, right. Okay, see, do one thing here. See, here you open circuit port 1, right? If you open circuit port 1, I1 will be 0. If I1 is 0 means this current source 4 into I1, 4 into 0 means this will become 0. Okay, then you're going to have the network like this. You're going to have the network like this. 2 ohms, 1 ohm. Okay, then this is V2. Then voltage at this point with respect to this point is V1. Okay, the current which is flowing this is 0. I1 will be 0. Then V1 is nothing but voltage across this 2 ohms. Voltage across this 2 ohms. Okay, so you use voltage division rule. Then voltage across this 2 ohms resistor. V1 is equal to that particular resistance is 2 by 2 plus 2 plus 1 into applied voltage V2. Then you can get the ratio V1 to V2. Okay, similarly you can find I2. Okay, the current which is flowing this is I2. So V2 is equal to I2 into 2 plus 1 plus 2. Then I can get the ratio I2 to V2. Okay, we don't have experiment like this. Okay, this is impedance. Okay, H11. Okay, H11 is impedance. H22 is admittance. Okay, so unit of impedance is ohm. Okay, this is measured in ohms. Okay, admittance is measured in Siemens. That's why 38 ohms, 0.2 Siemens. These two are having no units. Okay, H12 and H21 are having no units because their ratio of either here the H12 is what? H12 is the ratio of V1 to V2, ratio of voltage to voltage. Similarly, H21 is the ratio of current to current. So they are having no units.